We are told in this problem that we have a parabola with a certain vertex at -3, 2 and a certain focus at -3, 3. And we're asked for all the rest of the stuff about this parabola. So the way we're going to do this is breaking it down in parts. And let's start with those first two clues. I want to remind you where the focus of a parabola is and where the vertex is. Okay, the vertex is this spot at the very bottom. It's the minimum or the maximum if this parabola were upside down. It's the point where the parabola turns around. Okay, so that's your vertex. And your focus is this point sort of inside the parabola that the parabola seems to wrap around without touching. Now we've got a couple other vocab words in here. We'll just bang those out. We've got a line. Whoa, that went bad. Let's try this again. We've got a line right here called the directrix. And this sits below the parabola. It sits outside the parabola. And you've got an axis of symmetry. It's getting a little crowded here. Let me change the colors for a moment. You've got an axis of symmetry, which is just like any other axis of symmetry. It's what the parabola seems symmetric around. So that's going to travel between the focus and the vertex. It's the line connecting those two and extends beyond the parabola. So now that we have those ideas laid out here, let's see if we can put some of this together. First of all, the focal length. Okay, this is what I mean by focal length. This is the variable p in our equations. Okay, so the focal length for this guy, because this distance between the focus and the vertex is 1 unit, right here, whatever your unit is, it's 1 grid spacing, and I can tell that based on the vertex being at y equals 2, the focus being at y equals 3. Okay, they're 1 separated, so my focal length is 1. And the focal diameter is defined as simply 4 times the focal length. Okay, so this is going to be 4. And there's algebra reasons why that I'm not getting into. We've talked about those in class. The axis of symmetry, like I said, it's the line connecting the focus and the vertex. So really all you have to do is look at the x-coordinate in this case and come up with the axis of symmetry. That's going to be x equals -3. Now, before I breeze over that too quickly, this works as the axis of symmetry because I've got a vertical parabola, okay? In other words, it's a parabola that opens up. And a parabola that opens down would also be a vertical parabola, okay? Either up or down, those are verticals. And the axis of symmetry, therefore, is a line that goes up and down, and the parabola rotates around it. The equation of the directrix, now we have to start putting some pieces together here. If the directrix is a distance of the focal length below the vertex, right? Think about what that y value is. If we go from 3 at the focus down to 2 at the vertex, well, how much would you go down again to get to the directrix? Another step of 1, another focal length. So the equation of the directrix will therefore be y equals 1. It's a flat horizontal line that simply goes perpendicular to the axis of symmetry. Okay, so we've got a bunch of things written here. Now it's time to talk about the equation of the parabola. This is a big summary piece here. So if I'm going to write the equation of a vertical parabola, it's going to look like this. It's x minus h squared, and that equals 4p, in other words, the focal diameter, times y minus k. Okay? So it helps if you think about just a regular old parabola, right? If I drew a parabola like this, that looks like y equals x squared, right? Well, that's very similar to this structure we have here. There's a y on the right, and there's an x squared on the left. There's a lot of other stuff going on too. Let's get to that in a moment. But this is what the vertical parabola's equation is. And what we have to do here is substitute in some of these variables that we know. Now, h and k come from the vertex. Okay, so we can just read it right from the vertex. H is -3. So I can erase this negative h here and put +3. I can erase the minus k and replace that with -2. And see, this is almost done. And what is the focal diameter? 4p. Well, in this case, 4p is equal to 4. So that is my equation of this vertical parabola. And all that's left at this point is to draw the thing. So let's start with the vertex. I like starting with that best. It's at -3, 2. That's going to be right here. There's my vertex. And the focus, okay, hold on. The focus is the next bit, this part right here. That's -3, 3. So I'm going to draw that here. And then, let's see what else we want. We got the focus. I didn't actually need to plot the vertex. That's fine. So the directrix, that's going to be a line that goes across like this, forever in both directions. And the latus rectum, what is the latus rectum? Well, that is the line that cuts through the focus parallel to the directrix, so like this, but it has a length of the focal diameter. This is why it's called the focal diameter. It's the diameter of the parabola at the focus. Now, this becomes pretty easy. I've got the vertex down here, and my parabola needs to connect according to the latus rectum right there. The end points of the latus rectum are the sides of the parabola as it goes up. Okay, so this is basically what your shape is going to end up looking like. You won't have a point for the vertex when you draw it in the graphing program, but this is basically what we're looking at. And what you should notice is there are a couple of dots and lines and segments and things to help you out with this, this part of the problem. When you're drawing a dot, like for the focus, you're just going to use the dot piece. When you're drawing a line segment, that's just this guy. When you're drawing a line like the directrix, that's the one that goes off to infinity. And then, of course, you have to choose whether you want a vertical parabola or a horizontal parabola. In this case, we have a vertical, so we're going to select the vertical one. And that's it to this problem.